Earth's story is one of profound contrasts, a planet shaped by both relentless destruction and the quiet resilience of life. It is a narrative where chaos is the driving force, and catastrophe acts as both sculptor and muse. The tranquil world we know today, with its gentle tides, lush forests, and temperate climate, is not the result of calm beginnings. Instead, it is a hard-won triumph, forged in the fires of calamity. Over billions of years, Earth's history has been punctuated by violent upheavals, moments so transformative that they redefined the planet's destiny. Life itself is fragile, balanced on the edge of annihilation. Over 99% of all species that have ever existed are now gone, swept away by extinction-level events that forever altered the course of evolution. Entire ecosystems have vanished in the blink of a geological eye, wiped out by fiery volcanic eruptions, relentless ice ages, or the devastating impact of celestial objects hurtling toward Earth. And yet, these catastrophes did not simply end life's story. They fueled its evolution, forcing surviving species to adapt, evolve, and find new ways to thrive. Without these disasters, the rich diversity of life we see today might never have come to be. But among these countless upheavals, one event stands apart. A moment so violent, so profound, that it shaped the very fabric of the Earth itself. Billions of years ago, in the infancy of our solar system, Earth collided with a wandering planetary body the size of Mars. This catastrophic impact was not a mere episode in Earth's history, it was a defining moment. The collision obliterated the surface of the young planet, sending trillions of tons of debris hurtling into space. For an instant, it seemed Earth might be reduced to nothing more than a scattered field of rubble. And yet, from this violent chaos emerged one of the most important celestial objects in Earth's history, the Moon. The Moon's formation was not just a cosmic accident. It was the result of unimaginable forces that redefined Earth and made life possible. The Moon is far more than a passive satellite. Its gravitational pull has shaped the Earth's rotation, stabilized its axis, and ensured the predictable seasonal cycles that are vital for life. It has governed the tides, stirring the primordial oceans where the first molecules of life began to take shape. Without the Moon, Earth would be unrecognizable, a planet spinning wildly on its axis, battered by chaotic weather, and unable to sustain the delicate balance required for life to evolve. To fully grasp the significance of the Moon's creation, we must first understand the timeline of Earth's history. Imagine compressing the planet's 4.5 billion years of existence into a single 24-hour day. Midnight marks Earth's fiery birth, a time when it was a molten, hostile world. In the first few minutes of this day, the great collision with Teotl, a wandering planetary body, occurred. This impact was the first and most important catastrophe in Earth's history, setting into motion a series of events that would ultimately transform a barren planet into the cradle of life. The aftermath of the collision was both destructive and transformative. The force of the impact tore apart Earth's crust, scattering molten rock into space. This debris coalesced into a glowing ring of red-hot dust and rock, which slowly condensed over millions of years to form the Moon. But the Moon's influence did not end with its creation. Its gravitational pull began to slow Earth's chaotic spin, lengthening days and calming the violent storms that once swept across the planet. Its proximity generated massive tides that churned the oceans, creating the perfect conditions for the chemical reactions that would eventually give rise to life. The Moon's story is not just one of geology and physics, it is also one of wonder. For as long as humans have gazed at the night sky, the Moon has inspired myths, guided explorers, and sparked scientific curiosity. Ancient civilizations saw it as a deity, a timekeeper, and a source of light in the darkness. Its phases governed the rhythms of early agriculture, marking the passage of time and the cycles of planting and harvest. And in the modern era, the moon became the first celestial body to feel the touch of human hands, a milestone that forever changed our understanding of our place in the universe. For all its beauty and mystery, the moon's existence was far from inevitable. Without that ancient collision, Earth might have remained a barren, lifeless world, a planet spinning uncontrollably on its axis, its surface scarred by unrelenting storms. The moon's formation was not just a fortunate accident. It was a turning point in Earth's history, one that laid the foundation for everything that followed. This is a story of destruction and creation, of chaos and order, of how the violent forces of the universe gave rise to the delicate balance we see today. It is the story of the moon, an object born from catastrophe but essential for stability, and it is a reminder of how fragile and improbable life's journey has been. Without that collision, without the moon, we would not be here. In the following chapters, we will journey back in time to uncover the details of this ancient event. We will explore how the moon transformed Earth, setting the stage for life to begin. And we will reflect on the profound role that chance and catastrophe have played in shaping the world we call home. To understand the moon's origins, we must step back in time to the very birth of our solar system, over 4.5 billion years ago. This was an era of unimaginable chaos, when the sun was still young, burning with intense heat, and surrounded by a vast, swirling disk of gas, dust, and rock. Slowly, over millions of years, this material began to coalesce, forming the planets, moons, and asteroids that now make up the solar system. But this process was far from orderly. It was a time of violent collisions where newly formed worlds crashed into one another in a high-stakes game of cosmic billiards. Amidst this turmoil, Earth was taking shape. It began as a growing mass of molten rock, a fiery sphere constantly bombarded by smaller objects that added to its size. Each impact sent shockwaves rippling through its surface, melting rock and releasing immense energy. Slowly, Earth grew larger and more defined, but it remained a chaotic and inhospitable place. The volatile young planet without oceans, atmosphere, or even a solid crust. Elsewhere in the solar system, a planetesimal roughly the size of Mars was also forming. Known today as Theia, this proto-planet was one of many worlds that had emerged from the swirling chaos of the early solar system. For millions of years, Theia and Earth orbited the Sun in close proximity, their paths bringing them ever closer to an inevitable collision. This was not a small encounter. It was a meeting of giants, and the outcome would forever change the course of Earth's history. When Theia finally struck Earth, the event unleashed energy on a scale beyond comprehension. The collision was not a direct head-on crash, but a glancing blow, a sideswipe that ripped apart both worlds. The force of the impact liquefied much of Earth's surface, creating a planet-wide sea of molten rock. Debris from both Earth and Theia was ejected into space, forming a glowing halo of superheated material that would orbit Earth for millions of years. For a time, Earth was a planet in ruins. The impact had obliterated large portions of its crust, leaving a landscape of molten magma and shattered rock. The atmosphere was thick with vaporized material, blocking sunlight and creating a hellish, unrecognizable world. Theia itself was obliterated, its core merging with Earth's, while its outer layers became part of the orbiting debris. For all intents and purposes, Theia ceased to exist as an independent body, its remnants forever bound to Earth's fate. But amid this destruction, the seeds of creation were sown. The debris encircling Earth began to coalesce, pulled together by gravity. Over millions of years, this material gradually formed into a single, solid body, the Moon. At first, the Moon was far closer to Earth than it is today, just 1/500 miles away compared to past the more ebb and flow of life we call movements of the Earth and the sunset. From Earth's surface, it would have loomed unimaginably large, dominating the sky with its fiery glow. This collision was not just a moment of destruction. It was the beginning of a profound transformation. The Moon's formation marked a turning point in Earth's development, setting in motion a chain of events that would eventually make the planet hospitable to life. One of the most significant consequences of the collision was the tilt it gave to Earth's axis. Before the impact, Earth likely rotated with very little tilt, much like the planet Mercury does today, but the force of the collision knocked Earth off balance, tilting its axis by approximately 23 degrees. This tilt is what creates the seasons, as different parts of the planet receive varying amounts of sunlight throughout the year. Without it, Earth would lack the seasonal cycles that are so crucial for the diversity of ecosystems and climates we see today. The collision also altered Earth's rotation. Prior to the impact, Earth spun rapidly, completing a full rotation in just 6 hours. The Moon's formation introduced a new dynamic. Its gravitational pull began to act as a brake, slowing Earth's rotation over billions of years. This gradual deceleration lengthened Earth's days, transforming them from the frantic 6-hour cycles of the planet's youth into the 24-hour days we now take for granted. The Moon's creation also brought dramatic changes to Earth's surface. The gravitational pull of the Moon generated massive tides in Earth's nascent oceans, tides that were far more extreme than anything we see today. These immense tidal forces stirred the oceans, mixing chemicals and nutrients in ways that would later prove essential for the development of life. While the Moon's immediate effects were profound, the process of its formation was not quick. The debris from the collision took millions of years to fully condense into the Moon we know today. Early on, the Moon was a searing, molten sphere, glowing red with the heat of its formation. Over time it cooled, solidifying into the familiar gray and cratered surface we recognize in the night sky. For centuries, humanity could only speculate about the Moon's origins. Early myths and legends described it as a deity or a mystical object, a light in the darkness whose presence was both comforting and mysterious. It wasn't until the scientific revolution that astronomers began to understand the Moon as a natural satellite of Earth, and it would take centuries more for its true origins to come to light. The journey to uncover the Moon's story was long and filled with challenges. It wasn't until the mid-20th century, with the advent of space exploration, that scientists began to piece together the full picture. The Apollo missions provided the crucial evidence needed to confirm the Moon's origins, with samples of lunar rock revealing striking similarities to Earth's crust. These findings supported the idea that the Moon was formed from material ejected during a massive collision, a theory first proposed by planetary scientist Bill Hartmann. Today, we understand the collision with Theia not as a random accident, but as a pivotal event in Earth's history. It was a catastrophe of unimaginable proportions, but it was also a moment of creation, a cosmic reset that gave Earth the Moon and set the stage for the development of life. Without this collision, Earth might have remained a barren, chaotic world, spinning too rapidly to sustain a stable climate or the delicate processes needed for life to emerge. The Moon's creation was a turning point, a reminder that even in the face of destruction, the universe has a way of building anew. It was the first in a series of transformative events that would shape Earth into the thriving, life-supporting planet we know today. The collision that created the Moon was not an isolated event. It marked the beginning of a profound transformation for Earth. In the aftermath, the planet was left in a state of chaos, but this chaos carried the seeds of renewal. The young Earth, scarred and molten, began to reorganize itself. Over millions of years, the consequences of this cosmic event would ripple outward, reshaping the planet's surface, atmosphere, and potential for life. Immediately after the impact, Earth was a molten sphere, its surface an ocean of magma that glowed brightly in the cold blackness of space. The heat from the collision was so intense that it vaporized vast quantities of rock, sending plumes of molten material into the atmosphere and beyond. The sky above was filled with a swirling cloud of superheated gas and debris, casting Earth into an eerie twilight. From a distance, the planet would have appeared as a glowing, churning inferno, surrounded by a halo of red-hot rubble. The debris left in orbit formed a dense ring around Earth, a glowing band of molten fragments that would eventually coalesce into the Moon. But the immediate effects on Earth itself were equally profound. The impact had tilted the planet's axis, introducing a wobble that would shape its future climate. At the same time, the violent redistribution of mass triggered shifts deep within the planet, altering its internal structure and dynamics. As Earth began to cool, the changes set in motion by the collision became more apparent. The newly formed Moon, just 500 miles away, exerted a gravitational pull far stronger than it does today. This immense gravitational force generated tides unlike anything the Earth experiences now. Towering waves of molten rock and, later, water that swept across the planet's surface. These tides were not merely a result of the Moon's influence, they also acted as a force upon it, pulling the Moon gradually farther away. The Moon's gravitational pull also slowed Earth's rapid rotation. Before the collision, Earth spun so quickly that a full day lasted only 6 hours. This frantic pace created violent winds and storms as the atmosphere struggled to keep up with the planet's surface. The Moon, acting like a celestial brake, began to lengthen the days, gradually transforming the planet's weather patterns. The process was slow, unfolding over millions of years, but it was crucial in making Earth's climate more stable and predictable, a key factor for the development of life. Yet, in these early days, Earth remained an inhospitable place. The atmosphere was a toxic mix of gases, dominated by carbon dioxide, methane, and ammonia. Acid rain fell from the skies, and the surface was battered by meteorites from the still chaotic solar system. It was a planet defined by extremes, raging storms, searing heat, and a scale unimaginable today. Amid this chaos, the Moon began to take shape. Over millions of years, the ring of debris left in orbit started to coalesce, its fragments colliding and sticking together under the influence of gravity. At first, the Moon was a searing molten sphere, its surface glowing with the heat of its formation. Slowly, it cooled, and as it solidified, its features began to take shape. Impact craters formed as smaller objects collided with the Moon's surface, leaving scars that remain visible to this day. On Earth, the Moon's influence continued to shape the planet in profound ways. The tidal forces it generated began to stir the oceans, whence they formed, mixing nutrients and chemicals in a process that would later prove essential for the emergence of life. These immense tides also eroded the planet's surface, breaking down rocks and minerals and washing them into the seas. Over time, this process created a rich, nutrient-filled environment, a primordial soup. that would become the cradle of life. One of the most remarkable effects of the moon's formation was its role in stabilizing Earth's axial tilt. The tilt, caused by the impact with Theia, was critical for creating seasons, as it allowed different parts of the planet to receive varying amounts of sunlight throughout the year. However, without the moon, this tilt might have fluctuated wildly, causing dramatic and unpredictable climate shifts. The moon acted as a stabilizing force, anchoring Earth's tilt and ensuring the relatively consistent seasonal patterns we experience today. This newfound stability allowed the planet to begin recovering from the immediate effects of the collision. As Earth's surface cooled, the molten oceans of magma gave way to solid rock, and volcanic activity began to wane. The atmosphere, though still toxic, started to settle, and the first traces of water began to appear. Some of this water was delivered by comets, icy bodies that bombarded the planet during its early history. Other sources came from within the Earth itself, as steam released by volcanic eruptions condensed and fell as rain. The combination of liquid water, a stabilized climate, and nutrient-rich conditions set the stage for a profound transformation. Though life was still billions of years away, the ingredients for its emergence were slowly falling into place. The moon, a product of one of the most violent events in Earth's history, was quietly orchestrating the conditions that would one day make life possible. This period just after the moon's formation was one of the most critical in Earth's history. It was a time of extremes, but also of potential. A delicate balance where destruction gave way to creation. The collision that nearly destroyed Earth had not just given the planet the moon, it had set Earth on a path toward becoming a world capable of supporting life. The aftermath of this ancient collision reminds us that even the most violent events can lead to extraordinary outcomes. From the chaos of the early solar system emerged a stable, life-sustaining planet, guided by the quiet, persistent influence of the moon. The moon, born from a catastrophic collision, has never been a passive bystander in Earth's history. Its influence has extended far beyond the dramatic events of its formation, shaping the planet's evolution in subtle yet profound ways. Over billions of years, the moon has acted as a stabilizing force, a timekeeper, and a silent architect of Earth's environmental and biological systems. Without its steady gravitational presence, Earth would be a vastly different and likely inhabitable world. One of the moon's most critical roles has been stabilizing Earth's axial tilt. After the collision with Theia, Earth's axis was knocked to an angle of approximately 23 degrees. This tilt is what creates the seasons, as different regions of the planet receive varying amounts of sunlight throughout the year. However, without the moon, Earth's tilt would be far less stable. The gravitational pull of nearby planets, particularly Jupiter, could cause the axis to wobble chaotically over time. This instability would lead to erratic and extreme climate shifts, plunging the planet into cycles of freezing ice ages and scorching heat waves. The moon's gravitational pull prevents this chaos by anchoring Earth's tilt. Its steady influence ensures that the axial angle remains relatively constant, creating predictable seasonal patterns. This stability has been essential for the development of life, allowing ecosystems to adapt to regular changes in temperature, sunlight, and weather. The moon's role as Earth stabilizer is a quiet but critical aspect of its ongoing influence. Another major contribution of the moon is its effect on the planet's tides. The gravitational pull of the moon creates bulges in Earth's oceans, generating the rise and fall of sea levels that we know as tides. While the sun also influences tides, the moon's proximity to Earth makes it the dominant force. These tidal cycles are more than a simple rhythmic movement of water. They have played a fundamental role in shaping the Earth's environment and its living systems. Tides are a source of energy and motion, mixing the oceans and transporting nutrients across vast distances. In the planet's early history, when the moon was much closer, the tides were far more extreme. They surged inland with tremendous force, scouring the land and carrying minerals and organic material into the seas. These processes enriched Earth's oceans, creating a nutrient-rich environment that was crucial for the emergence of life. Even today, the moon continues to shape marine ecosystems. Tidal currents influence the migration patterns of countless species, from tiny plankton to massive whales. Coastal habitats, such as mangroves, estuaries, and tidal flat, depend on the ebb and flow of tides to sustain their unique ecosystems. The moon's pull creates dynamic environments where species have evolved to thrive, making it a quiet driver of biodiversity. The moon's influence extends beyond physical forces. It has also acted as a cosmic clock, regulating time on Earth. In the planet's early history, days were short, lasting just a few hours. Over billions of years, the moon's gravitational pull has slowed Earth's rotation, gradually lengthening the day. This process, known as tidal friction, occurs as the tidal bulges created by the moon drag against Earth's surface. Today, a full day lasts 24 hours, but this was not always the case. The lengthening of days has had a profound effect on life's evolution. Early organisms adapted to the shorter days of ancient Earth, but as the planet's rotation slowed, the extended periods of daylight and darkness influenced the behavior, metabolism, and reproduction of countless species. The gradual shift toward longer days created new opportunities for life to adapt and diversify, contributing to the rich tapestry of ecosystems we see today. In addition to shaping the physical world, the moon has left an indelible mark on humanity's cultural and scientific history. For millennia, it has been a source of inspiration and wonder, a constant presence in the night sky that has shaped human thought and creativity. Ancient civilizations used the moon to mark the passage of time, creating lunar calendars that governed agricultural cycles, festivals, and rituals. Its phases became symbols of renewal and transformation, woven into the myths and stories of cultures around the world. The moon has also guided exploration and discovery. Its light illuminated the paths of ancient travelers, and its predictable cycles helped early navigators find their way across vast oceans. In the modern era, the moon became a symbol of human achievement, as the Apollo missions of the 20th century made it the first celestial body to be explored by humans. The samples brought back from its surface not only revealed its origins, but also deepened our understanding of Earth and the solar system. Looking forward, the moon continues to play a vital role in humanity's plans for the future. Its surface is a potential resource for scientific research and space exploration. Plans for lunar bases and mining operations suggest that the moon could serve as a stepping stone for missions to Mars and beyond. Its influence, both practical and symbolic, remains as strong as ever. The moon's ongoing impact on Earth is a reminder of the interconnectedness of celestial and terrestrial systems. Its gravitational pull shapes our tides, its presence stabilizes our seasons, and its rhythms have guided life and culture for billions of years. It is both a product of catastrophe and a quiet architect of order, a celestial companion that has been shaping Earth's destiny since the moment of its creation. The moon's creation was not just a geological event. It was a turning point that profoundly influenced the evolution of life on Earth. Over billions of years, the moon has played a quiet but pivotal role, shaping the conditions necessary for life to emerge and thrive. Its gravitational pull, its effect on Earth's rotation, and the stability it brings to the planet's tilt have all contributed to the delicate balance that makes Earth habitable. Without the moon, the story of life might have unfolded very differently. Or perhaps not at all. In Earth's earliest days, following the collision with Theia, the planet was a violent and chaotic place. But even as the moon began to coalesce from the debris of the impact, its gravitational influence was already shaping Earth's destiny. One of its first contributions was the creation of immense tides in the planet's nascent oceans. These tides, far more extreme than those we see today, surged across the planet's surface, churning the water and mixing it with minerals and nutrients from the land. This process, known as tidal mixing, was crucial for the formation of what scientists call the primordial soup. The churning tides transported essential chemicals into the oceans, creating an environment rich in the building blocks of life. In these nutrient-filled waters, molecules began to interact, forming increasingly complex structures. Over time, this process gave rise to the emergence of life. The tidal forces generated by the moon also created a dynamic environment where chemical reactions could occur repeatedly and under varying conditions. Pools and tidal flats, alternately submerged and exposed by the massive tides, became natural laboratories for these reactions. Scientists believe that these environments, where water and land constantly mixed, were ideal for the formation of the first protocells, the precursors to living organisms. As life began to emerge, the moon continued to shape its development. Its influence on Earth's rotation slowed the planet's frantic 6-hour days, gradually lengthening them to the 24-hour cycles we know today. This change had a profound impact on the early biosphere. Longer days meant longer periods of sunlight, allowing photosynthetic organisms to flourish. Cyanobacteria, some of Earth's earliest life forms, used sunlight to produce energy. This process, known as photosynthesis, was a revolutionary moment in Earth's history. It not only transformed the atmosphere, filling it with oxygen, but also paved the way for the evolution of complex life. However, this transformation was not without its challenges. The sudden increase in oxygen was toxic to many early organisms, triggering one of the planet's first mass extinction events. Yet for those that survived, this new atmosphere opened up extraordinary possibilities, allowing for the development of larger, more complex life forms. The moon's stabilizing effect on Earth's axial tilt was another key factor in the evolution of life. By preventing dramatic shifts in the planet's tilt, the moon ensured relatively consistent seasonal cycles. This stability allowed ecosystems to adapt and flourish, as life could evolve in response to predictable patterns of temperature, light, and weather. Without this stability, Earth's climate might have oscillated wildly, making it far more difficult for life to gain a foothold. The moon's influence also extended to the tides, which played an ongoing role in shaping coastal and marine ecosystems. These tidal forces created unique habitats, such as intertidal zones, where life had to adapt to alternating periods of submersion and exposure. Over time, these challenging environments became hotbeds of evolution, fostering the development of organisms capable of surviving in both aquatic and terrestrial conditions. It is no coincidence that some of Earth's first life forms transitioned from the oceans to the land in regions shaped by tidal forces. The moon's pull not only created these environments, but also drove the nutrient cycles that sustained them. For early life, the moon was an unseen ally, a force that quietly shaped the conditions necessary for survival and adaptation. As life became more complex, the moon's influence remained a constant. Its gravitational pull continued to drive the tides, influencing the migration patterns of marine species and shaping the reproductive cycles of countless organisms. For some species, the moon became an integral part of their biological rhythms, with lunar cycles dictating behaviors such as spawning and nesting. The moon's role in the evolution of life is a testament to the interconnectedness of Earth's systems. Its formation was a violent and destructive event, and yet its presence has been a source of stability and order ever since. Without the moon, Earth would lack the tides, the stable climate, and the predictable cycles that have allowed life to flourish. Even today, the moon continues to shape life on Earth in ways both subtle and profound. Its gravitational pull governs the ebb and flow of the tides, creating habitats and influencing ecosystems. Its light, though dim compared to the sun, has guided countless species for millions of years, from the migrations of sea turtles to the hunting patterns of nocturnal predators. The moon's story is a reminder that even the most violent beginnings can give rise to extraordinary outcomes. It is a quiet architect of life, its influence felt in every corner of the planet. From the formation of the first molecules in the primordial soup to the evolution of complex organisms, the moon has been a constant companion in Earth's journey, shaping the conditions that made life possible. The moon's presence has been so deeply intertwined with Earth's history that it's difficult to imagine our planet without it. Yet, exploring a hypothetical Earth without a moon reveals just how essential this celestial companion has been. Without the moon, Earth would be an entirely different world, one likely hostile to the emergence of life and incapable of sustaining the ecosystems we know today. One of the most significant consequences of a moonless Earth would be the loss of axial stability. As Earth spins, its axis is tilted at an angle of roughly 23 degrees, giving us our seasons. The moon acts as a stabilizing force, keeping this tilt relatively constant. Without the moon's gravitational influence, Earth's tilt would fluctuate unpredictably, wobbling chaotically over time. This instability would have catastrophic effects on the planet's climate. At times, the tilt could become extreme, with one hemisphere experiencing constant, unrelenting sunlight, while the other is plunged into perpetual darkness. These conditions would lead to devastating temperature extremes, scorching heat on one side of the planet and frigid cold on the other. Over millennia, these shifts could reverse, creating cycles of climate chaos that would make it nearly impossible for ecosystems to adapt. The absence of the moon would also mean the loss of tides as we know them. While the sun does exert a gravitational pull on Earth, creating small tides, these are far weaker than those driven by the moon. Without the moon's influence, Earth's tides would be minimal, and the powerful tidal forces that helped stir the primordial oceans and foster early life would never have existed. This lack of tidal mixing would have profound consequences for Earth's oceans. Tides play a crucial role in distributing nutrients and oxygen throughout marine environments, supporting a vast array of life forms. In a world without significant tides, oceanic ecosystems would stagnate, limiting the availability of essential nutrients and reducing the diversity of marine life. Coastal regions, which are shaped and sustained by tidal forces, would also cease to exist, eliminating vital habitats for countless species. Earth's rotation would also be vastly different without the moon. In the planet's earliest days, a day lasted just 6 hours. The moon's gravitational pull has gradually slowed Earth's rotation over billions of years, giving us the 24-hour days we experience today. Without the moon, this deceleration would never have occurred, and Earth's rapid rotation would create violent winds and extreme weather patterns. The shorter days would also reduce the amount of time available for photosynthetic organisms to generate energy, potentially stalling the development of complex life. The absence of the moon would not only affect Earth's physical environment, but also its cultural and scientific history. For millennia, the moon has served as a guide and inspiration for humanity. Ancient civilizations used its phases to mark time, creating calendars that governed agricultural practices and rituals. Its light illuminated the night for early humans, influencing their behavior and shaping their myths and stories. Without the moon, our ancestors would have been left with a darker, less navigable night sky, profoundly altering the course of human development. The moon's influence also extends to the field of astronomy and space exploration. Its presence has provided scientists with a nearby laboratory for studying the origins of the solar system. The moon's surface, untouched by erosion or weather, preserves a record of impacts and events dating back billions of years, offering invaluable insights into Earth's own history. Without the moon, much of this knowledge would be lost, leaving us with a less complete understanding of our planet and its place in the cosmos. Looking to the future, the moon remains a cornerstone of humanity's aspirations for space exploration. It is seen as a stepping stone for missions to Mars and beyond, offering a nearby environment for testing technologies and developing sustainable living systems. The moon's resources, such as water ice in its polar regions, could one day support permanent human settlements and provide fuel for interplanetary travel. A world without the moon would lack this crucial gateway to the stars, limiting our potential to explore and expand beyond Earth. In considering a moonless Earth, it becomes clear just how much we owe to this silent companion. From the stability of our climate, to the rhythms of our oceans, from the inspiration it has provided to the scientific knowledge it has unlocked, the moon's presence has shaped Earth in ways both seen and unseen. Without it, our planet might have remained a chaotic, lifeless sphere, spinning too rapidly and lacking the conditions necessary for life to emerge and thrive. The moon's story is a reminder of the delicate balance that makes life on Earth possible. It is a testament to the interconnectedness of celestial and terrestrial systems, where even the smallest changes can have profound consequences. In its absence, we see not just the challenges Earth would face, but also the extraordinary role the moon has played in making our world what it is today. The moon's journey is not over, and neither is its influence on Earth. Over billions of years, the moon has been slowly drifting away from its host planet, moving at a rate of about 1.5 inches per year. Though this may seem negligible on human timescales, it is a reminder that the relationship between Earth and the moon is not static. As the moon continues its slow retreat, the consequences for Earth will unfold across millennia, subtly but inevitably altering the planet's environment and the systems that life depends upon. One of the most immediate effects of the moon's gradual distancing is its impact on Earth's rotation. The moon's gravitational pull has been slowing Earth's spin since its formation, and this process will continue as long as the moon remains in orbit. As the days grow longer, the effects will be subtle at first, but over billions of years they could add up to dramatic changes. Days that currently last 24 hours may stretch to 30 or 40 hours, fundamentally altering the rhythms of life on Earth. The moon's retreat will also weaken its gravitational influence on the tides. Over time, Earth's tides will become less dramatic, with lower highs and less pronounced lows. This will have significant effects on coastal ecosystems, which rely on the ebb and flow of tides to sustain biodiversity and transport nutrients. Estuaries, wetlands, and other tidal habitats may shrink or vanish entirely, disrupting the species that depend on them. The moon's stabilizing effect on Earth's axial tilt will also diminish as it moves farther away, while the moon's pull will remain strong enough to keep Earth's tilt relatively stable for the foreseeable future. Its retreat could eventually allow other gravitational forces, such as those exerted by the Sun and Jupiter, to exert greater influence. Over time, this could lead to greater variability in Earth's tilt, potentially triggering shifts in the planet and seasons. In the distant future, billions of years from now, the Moon's retreat may reach a critical point. At some stage, Earth and the Moon will enter what is known as a tidal lock, a state where the Moon will no longer drift away, but both bodies will face each other with the same side perpetually visible. At this point, Earth's rotation will match the Moon's orbital period, creating a scenario where one side of Earth always faces the Moon and the other side never does. This would profoundly alter Earth's tides, climate, and perhaps even the behavior of life on the planet. The Moon's long-term future is also tied to the fate of the Sun. In approximately 5 billion years, the Sun will enter its red giant phase, swelling to many times its current size. As the Sun expands, it will engulf the inner planets, likely including Mercury and Venus. The fate of Earth and the Moon in this scenario is uncertain. Some models suggest that Earth might be pulled into the Sun's fiery embrace, while others propose that the planet and its satellite could survive, orbiting the remnants of the Sun, a dense white dwarf. Even if Earth and the Moon survive the Sun's transformation, their relationship will be fundamentally altered. The loss of solar energy will drastically change Earth's climate, potentially freezing the planet and ending the ability to sustain life as we know it. The Moon, still tethered to Earth, may become a cold and desolate companion, its influence over a lifeless planet reduced to silence. Despite these distant and dramatic possibilities, the Moon's current influence on Earth remains vital. It continues to shape our tides, stabilize our seasons, and guide life's rhythms. And as humanity looks toward the future, the Moon's role may become even more significant. In the coming decades and centuries, the Moon is poised to play a critical role in humanity's exploration of space. Plans for lunar bases are already being developed, with countries and private companies envisioning permanent settlements on the Moon's surface. These outposts could serve as staging grounds for missions to Mars and beyond, providing a platform for scientific research, resource extraction, and the development of sustainable life support systems. The Moon's resources, such as water ice found in its polar regions, could prove invaluable for future space exploration. This ice can be converted into water, oxygen, and even rocket fuel, enabling longer and more ambitious missions. The Moon may also become a hub for manufacturing and assembly in space, reducing the costs and risks associated with launching materials from Earth. As humanity expands its presence beyond Earth, the Moon could play a central role in ensuring our survival. Its proximity and resources make it an ideal testing ground for the technologies and strategies needed to establish a permanent human presence in space. By using the Moon as a stepping stone, humanity could one day explore the far reaches of the solar system and beyond, carrying the legacy of Earth to new worlds. The Moon's journey, like Earth's, is far from over. It began as a product of chaos, born from a catastrophic collision that nearly destroyed Earth. Over billions of years, it has shaped the planet, fostering the conditions necessary for life to emerge and evolve. Now, as the Moon continues its slow retreat, it remains a constant reminder of the interconnectedness of the cosmos, a celestial companion that has shaped our past and will continue to influence our future. The Moon's creation was just one chapter in a much larger story, a saga of cosmic violence and renewal that has shaped the destiny of Earth. Catastrophes, both immense and minute, have acted as the architects of our world, each one a turning point that brought Earth closer to becoming the cradle of life. From the fiery collision that birthed the moon, to the ice ages, volcanic eruptions, and asteroid impacts that followed, these events reveal a profound paradox. Destruction has often been the prelude to creation. The first in this long chain of catastrophes was, of course, the collision with Theia. The violent impact created not only the moon, but also the conditions necessary for Earth's transformation. In the billions of years that followed, Earth endured countless upheavals, each one shaping the planet in ways that would pave the way for life to emerge. In its early history, Earth faced a relentless bombardment from space, a period known as the Late Heavy Bombardment, around 4 billion years ago. During this time, the planet was struck by countless asteroids and comets, their impacts vaporizing surface materials and sending shock waves through the young planet. At first glance, this period of bombardment appears purely destructive, a chaotic assault that could have obliterated any chance of life. But these impacts were also a blessing in disguise. Many of the comets that collided with Earth carried water, delivering the precious resource that would eventually fill Earth's oceans. The impacts also delivered essential elements such as carbon, nitrogen, and phosphorus, which became the building blocks for organic molecules. These collisions enriched the Earth, setting the stage for the complex chemistry that would later give rise to life. The birth of life itself was not a singular moment, but a gradual process, driven by the interplay of the planet's changing conditions. The churning oceans, stirred by the moon's powerful tides, became a crucible for chemical reactions. In these nutrient-rich waters, simple molecules began to combine, forming amino acids, proteins, and eventually the first protocells. These primitive cells marked the dawn of life, the beginning of journey. Even after life emerged, it was far from safe. The planet's history is marked by a series of mass extinctions, each one wiping out vast numbers of species, but also creating opportunities for new forms of life to evolve. One of the earliest such events was triggered by cyanobacteria, the first organisms to harness sunlight for energy through photosynthesis. This process released oxygen as a byproduct, transforming Earth's atmosphere and oceans. For many organisms, this sudden influx of oxygen was lethal, leading to a mass extinction, often referred to as the Great Oxidation Event. But for others, it was an opportunity. The presence of oxygen allowed for the development of more complex metabolic processes, paving the way for multicellular life. This catastrophe, oxygen's arrival, was a turning point, a moment when life transitioned to new and more complex forms. Other catastrophes followed. Around 2.4 billion years ago, the planet entered a period of severe glaciation known as the Snowball Earth event. The entire planet was encased in ice, with temperatures plummeting and life confined to a few refuges beneath the frozen surface. Yet, this freezing period may have played a key role in shaping the planet's evolution. The intense glaciation triggered massive chemical changes in the oceans, enriching them with nutrients that would fuel the explosion of life once the ice receded. Perhaps the most famous catastrophe in Earth's history occurred 66 million years ago, when a massive asteroid struck the Yucatan Peninsula, triggering the extinction of the dinosaurs. This event, known as the Cretaceous Paleogene extinction, wiped out nearly 75% of all species on Earth. But in the wake of this destruction came a remarkable opportunity: the rise of mammals. Freed from the shadow of the dinosaurs, mammals diversified and flourished, eventually giving rise to primates and, ultimately, humans. Each of these events underscores a profound truth about Earth's history. Catastrophe is not just an end, but also a beginning. The destruction wrought by these events created new environments, reshaped ecosystems, and cleared the way for new forms of life to thrive. Without them, the diversity of life we see today, indeed, life itself, might never have existed. Even now, Earth remains vulnerable to catastrophe. The planet continues to face threats from space, such as asteroid impacts, and from within, such as supervolcanoes. These events, though potentially devastating, are also reminders of the forces that have shaped our world. They are part of the same process that created the conditions for life, a testament to the dynamic and ever-changing nature of the Earth. The Moon, too, plays a role in shielding Earth from some of these dangers. Its gravitational influence helps stabilize the orbits of near-Earth asteroids, reducing the likelihood of catastrophic impacts. The Moon's craters are a testament to the many impacts it has absorbed over billions of years, acting as a silent protector for its host planet. As we look to the future, humanity faces a choice: to prepare for these inevitable events, or to ignore the lessons of Earth's history. Understanding the role of catastrophe in shaping the planet can inspire us to protect it, to learn from its past, and to build a future that respects the delicate balance that makes life possible. In the end, the long chain of catastrophes that have shaped Earth is a story of resilience. It is a story of how a planet, battered by cosmic and geological forces, became a cradle of life. It is a story that reminds us of the fragility of our existence and of the extraordinary conditions that allow us to be here at all. The Moon story is not just about science or the mechanics of celestial bodies. It is also a deeply human story. For millennia, the Moon has been a constant companion, a light in the night sky that has inspired awe, curiosity, and imagination. It is woven into the fabric of human culture, from ancient myths and legends to modern science and exploration. In many ways, the Moon serves as a mirror, reflecting not just the story of Earth's creation, but also the ingenuity and wonder of humanity. To ancient civilization, the Moon was a symbol of mystery and power. Its changing phases marked the passage of time, influencing the development of calendars, agricultural cycles, and religious rituals. Cultures around the world wove the Moon into their myths and stories, often associating it with gods, goddesses, and the rhythms of life and death. In China, the Moon Festival celebrates unity and harmony, while in ancient Greece, the goddess Selene was believed to drive her chariot across the night sky, bringing the Moon's light to the Earth. These cultural connections are not merely historical curiosities. They demonstrate humanity's deep bond with the Moon. Its phases and cycles have shaped the way we perceive time and the universe, providing a sense of order and continuity in an ever-changing world. For early humans, the Moon's presence was a source of comfort and guidance, illuminating the darkness and offering a sense of connection to the cosmos. As humanity advanced, so too did our understanding of the Moon. By the time of the scientific revolution, astronomers like Galileo Galilei were studying the Moon's surface, using telescopes to reveal its craters and mountains. The Moon was no longer a divine entity but a physical object, a world in its own right. This shift marked the beginning of a new era in humanity's relationship with the Moon, one defined by exploration and discovery. The pinnacle of this exploration came in 1969, when astronauts from NASA's Apollo program landed on the Moon. For the first time, humans set foot on another celestial body, an achievement that captured the imagination of the world. The Moon landings were not just a triumph of engineering and science. They were a moment of profound significance, a testament to humanity's capacity for curiosity and innovation. The samples brought back from the Moon's surface revealed its ancient origins and its connection to Earth, deepening our understanding of the solar system. These missions also transformed the way we view our own planet. From the surface of the moon, astronauts gazed back at Earth, seeing it as a fragile blue marble floating in the vastness of space. This perspective inspired a new awareness of the interconnectedness of all life on Earth and the need to protect our planet. Today, the moon continues to inspire humanity's aspirations. It is seen as a stepping stone for future exploration, a place where we can test the technologies and strategies needed for interplanetary travel. Plans for lunar bases, mining operations, and scientific research are already underway as nations and private companies look to the moon as a gateway to the stars. The moon's significance, however, goes beyond its practical value. It reminds us of our place in the universe, of the delicate balance that makes life possible, and of the extraordinary journey that brought us here. The moon is a testament to the power of curiosity and imagination, a symbol of what humanity can achieve when we look beyond our immediate horizons. In reflecting on the moon, we are reminded of the profound interconnectedness of all things. The moon exists because of a cosmic collision billions of years ago, a moment of chaos that gave rise to stability and order. It has shaped Earth's tides, seasons, and climate, creating the conditions necessary for life. And it has inspired humanity to explore, to question, and to dream. As we continue to study and explore the moon, we are not just learning about its surface or its history. We are learning about ourselves. The moon's story is our story, a reminder of the fragile and extraordinary nature of life on Earth. It is a reflection of our past, a guide to our present, and a beacon for our future. A silent companion that has been with us every step of the way. This brings us full circle to the realization that the moon, born from catastrophe, has become a symbol of hope and possibility. It is a reminder that even in the face of destruction, new beginnings are possible, and that the universe, in its vastness, holds endless opportunities for wonder and discovery. The moon has been a steadfast presence in Earth's sky for over 4 billion years, its silent vigil a testament to the extraordinary events that shaped our planet. Of purpose, born from a catastrophe that nearly destroyed the young Earth, the moon's story is a reminder that even in the aftermath of chaos, creation can emerge. It is a symbol of resilience, a cosmic artifact that encapsulates the delicate interplay of chance and necessity that defines our existence. Without the moon, Earth would be a different world, its climate unpredictable, its days shorter, and its oceans devoid of the dynamic tides that nurtured the first stirrings of life. The moon has done more than reflect sunlight in the night sky. It has stabilized Earth's axis, slowed its rotation, and shaped its tides, creating the conditions necessary for life to evolve and flourish. Yet, the moon's significance goes beyond the scientific. For humanity, it has always been a source of inspiration and wonder, a beacon in the darkness that has guided our ancestors and sparked our imaginations. From ancient myths to the Apollo landings, the moon has been a canvas on which we project our dreams and aspirations, and our reminder of the vastness of the universe and our place within it. The moon's story also reveals the fragility and interconnectedness of life on Earth. It is a reminder that the conditions we take for granted, the stable climate, the rhythmic tides, the predictable seasons, are the result of billions of years of cosmic events and delicate balances. It is a reminder that we are part of a larger story, one that began long before us and will continue long after we are gone. As humanity looks to the future, the moon remains central to our aspirations. It is the next frontier for exploration, a proving ground for the technologies and strategies that will carry us to Mars and beyond. Its resources could fuel our journeys to other worlds, ensuring that the spirit of exploration that has defined humanity will endure. But as we venture outward, the moon also reminds us to look inward. To appreciate the unique and extraordinary planet we call home. It reminds us of the importance of protecting Earth, of cherishing the delicate balances that make life possible, and of striving to understand the forces that have shaped our world. The moon is more than a celestial object. It is a witness to Earth's journey, a silent companion that has shaped our history and our destiny. Its story is a story of resilience, transformation, and wonder, a story that continues to unfold with each passing day. Let us remember, as we gaze at the moon in the night sky, that we are part of a universe filled with possibilities. The moon, born from chaos, stands as a symbol of hope and renewal, a reminder that even in the face of destruction, new worlds can be forged and life can endure.